I knew I shouldn't have joined.
Good morning, good afternoon, good evening. Everybody's quiet. We're going to do this. And welcome to another episode of Being Very Silly. And this is the LMTV, where is Tony Fortunato, WTF Live. We're very happy to have Tony come on the show. And I don't know if this is going to be a ritual or not, but Tony just published another paper on network computing, and so we thought that it would only be fair if we come on our show to talk about a paper that he wrote in someone else's website. Right, Tony?
That's exactly right.
Yeah,
that's right.
Why not?
And I got a couple extras. I got a couple of extras for the Love My Tool audience that is not in the article.
Yeah, no, I think it's great. I think it's great. We're here to build a community, so the more the merrier. So before we turn the table, we turn the podium to you. Let me introduce some of our fellow panel members. First of all, I'd like to introduce Chris Greer.
Good morning, good afternoon, good evening.
And so Chris, like I said, you need to come on the show more often. Because otherwise, okay, that's it. Okay,
Let's do it. You're right. You're right. You got me.
And then next, I'd like to introduce Paul Orford.
Hi, everyone. I'm from the UK, and Chris, you're going to have to come on more often because Tony's getting to a level where he just won't want to talk to us soon. So
that's right.
We need someone else.
Okay.
And finally, Tim. Good morning, good evening, good afternoon.
Hello, everybody. Glad to get all these guys out of jail and get us all together once.
Yeah. And welcome to the one and only show where we don't ask for your sexual preference.
That's right.
that's an inside joke. Sorry. That's just an inside joke between Tony and Tim. Okay, enough fun. Tony, get serious. So you wrote a paper recently, and was it a new topic? Was it a kind of a re-representation of something that you think about before?
It's a combination of two things. I do talk about this concept many times, but I was just working on a job, and we were troubleshooting, and this very issue came up. So I showed the customer, and I talked about what the issues were and what they were missing and why they were missing it. And they were shocked. They had never thought of that before. And I thought, hey, why not write this up? I've never actually concentrated on this topic. So I whipped it up, and the folks at Network Computing said, hey, that's awesome. We've never seen that written up like that before. Let's post it. Sure. So here we are. Mm-hmm. So I've just written up a quick couple-minute video for them, and I'm going to review the slide with you folks.
Good. Back in the days when I was in academia, we make a big deal about peer review, and so so think about this as the second half of your paper where we actually get to do some peer review. So I look forward to hearing feedback from Paul. You got your pencil all sharpened, right?
Yep, and a nice big piece of paper. So away we go.
You got your A-size paper all ready to go?
Yeah, it's there.
Okay. Well then that's it. Tony, take it away.
All right, let me go to my screen share here. Wow, the comedy never ends. Okay, folks. So right now everybody should see my PowerPoint, I'm hoping. And this is a slide in the video. And the big deal about the video was tool placement. And this is kind of a big deal because people are going towards application performance, monitoring tools, reporting tools, and just basic any tools, Wireshark, any protocol analyzer this applies to. And it's a very simple concept, but when you're troubleshooting, it's easy to miss this. So on the left-hand side, here's our client, and he sends a data packet, and off it goes, and it gets to the other end. And right after that, there's another data packet, and there's a 1 millisecond delta time between the two. Now let's assume the absurd that the whole network has no latency, just to keep things easy for us, and it arrives at the other end at 1 milliseconds. Well, when he sends packet 3, 19 milliseconds after that other one, it doesn't make it. So he's got to wait, and he's going to retransmit. And let's just assume it takes 200 milliseconds for the sender to decide, hey, this isn't working out, I have to resend this packet. off it goes, and it arrives at the other end, not at 200, but 219, because you have to add the first 19 milliseconds of the one that never got there. So we get our acknowledgement back. So from the client side, if you were troubleshooting from his side, he obviously knows there's a retransmission because he resent data 3 twice at 19 and 200 millisecond point. But if you were on the server side, the receiving side of the network, you don't see that, obviously, because the packet never got there. So you just see 200 milliseconds, 219 milliseconds, pardon me, of delay. So from the receiving side, it looks like either the network / cloud, whatever you want to call it, has provided a tremendous amount of delay. Or you might want to really get finicky and blame the client and say, hey, it's 219 milliseconds from the client's end, the PC's slow, there's your problem, get lost. So this is it's a very, very simple concept that if you don't position yourself on the right side of the network, or the correct side, or as I always say, the sending side, you're going to miss that. I've already gotten a lot of feedback from people from the article, and they were asking me for tips and tricks on what would you look for to find out if it really got there or didn't get there. Well, if you use TCP, just as a quick example, TCP, if you are using something called SACK, S-A-C-K, pardon me, or selective acknowledgments, you would see evidence of possibly something called an SRE or an SLE, a selective left edge or right edge. And that would tell you basically, hey, I got everything up to this point, but I only have everything after this point. So you get an indication that something might be missing. You might also, if you're really lucky, you might see a retransmission, that sort of thing. But in some cases, you might not. Depends on where this packet is missing. If it's at the end of the stream, which is quite possible, then you're not going to see that. So from that, just a little something extra that I added that I did not put in the article. This is an extra one called lost packets or errors, and it's the same kind of idea. In this case, the client sent packets 1, 2, and 3, and on this side we get 1 and 3. So one thing that I suggested to people who had commented to me was, hey, if you know the IP identifier, then you would see the IP identifier increasing and you would see numbers missing. That's one thing. That's a good clue or indicator that you've dropped packets on your network. The other one that's a little, I'm going to say, a little more obvious is when you send 1, 2, 3 from the client, goes through the network and they arrive in a different order, 3, 1, 2, for example. And that's obvious because I did get all 3 of them, but they're out of sequence. The reason why I bring this one up is I run into more and more protocols that do not like being out of order, especially when they run directly over UDP. UDP doesn't have that sequencing advantage that TCP has. UDP doesn't have the built-in acknowledgments that TCP does. So with UDP, when things get out of order and it's bad enough, and the application decides what bad means, then, for example, 312 might result in the connection getting reset or disconnected or rejected, that sort of thing. And if it's audio or video, you might notice that drop in audio or the video kind of pauses every once in a while. And at the end of all this, another I'm going to say reader commented on my video and said, hey Tony, is there a way to find out from my machine if I don't have tools that stuff is not working out? And I said, yeah, sure. With most operating systems, I'm going to just throw that blanket statement out. You can go with netstat --s, and you can type that in the command prompt or terminal window, whatever your operating system calls it. And under TCP, because it's built into TCP, there's a retransmitted counter. And that's kind of good because when you're sending data, and this is the key part, you have to send data. If you're receiving data, then this doesn't help as much. If I'm sending data, then I'm tracking what's being sent, and guess what? I would know if I resent the same thing twice. So just by looking at that number, you can find out if you're retransmitting. Unfortunately, from the command line, there's no real easy way, for example, with Windows, to clear that counter. So the worst case scenario is you pay attention to that number. Let's just look at this one, for example, 104,832, 104,000. And you would run your application again or your upload again or whatever you're doing. And if that number jumps up to 200,000, well then guess what? You had a whole lot of retransmissions. But don't stop there, and this is where people I find really pigeonhole themselves. If that number doesn't change, people say, oh, what a waste of time. And I say, well, no, that's not a waste of time because you just proved what it is not. It's not a retransmission issue. So there's a lot of ways of getting visibility into that same problem. But again, just going back to the original slide, this is a major problem because I find that people with application performance monitoring or measurement tools, if they're not putting them in the right spot, then they're going to misreport latency-related issues. And if you're troubleshooting with Wireshark or whatever protocol analyzer you happen to be using, you're going to have the same issue. The only thing that I find to be a bit of a wild card in all of this is how you capture the data. And that's obviously, we've spoken about this before. The ideal scenario is you capture from the device that's sending the data, obviously. If you can't do that for whatever reason, then you go to plan B, which is obviously some sort of tap, because the tap's not going to drop the packets. You know, that's obviously a good way to go. Option 3, you know, you can go with your typical span or mirror port, but then we all know that you may have issues with that. And lastly, if you're receiving data and it's corrupted, then you may not get it because your operating system might not pass that on to the protocol analyzer. So there's a couple of extra points that were brought up and with the feedback from the article that wasn't in the video that I thought I would share with the Love My Tool audience. But that's basically it, and I'm sure Chris and Paul know that this very simple topic can spin out into hours of conversation. So I'm just gonna drop it there, and I'm gonna stop sharing my screen, and there you go.
Okay, who goes first?
I'll say something. Oh, I'm getting echo now. One of the issues is the impact of latency on retransmission timeouts. If you start to get a lot of retransmissions over long distances, so we were recently looking at a problem where the users were in Australia and the systems were in the UK. Even with SAC, because you have to detect the timeout of a packet, and the timeout is usually twice the round trip time. You've got a 300 millisecond round trip time from Australia to the UK. Your timeout then is double that. You've only got to lose a couple of packets, and the impact on performance is tremendous. And I think that an understanding of that whole retransmission mechanism aligned with what you said about having traces in matching traces both ends are great. I think that really does ease the workload in analysing the performance issues that you get with this sort of problem. That's
yeah, you know what? That would be a great topic. Hey, Paul, if we did a little talk on TCP retransmission and SAC and RTOs and all that kind of stuff, right? Because that's something that I don't think a lot of people totally understand. They just know it happens, right?
Yeah. Okay, I think now we should hand over to the TCP guru because he's itching to get in there. So let's let him get in here. You know who I mean, Chris. Come on.
Go ahead, Tim. Go ahead.
No, you go first, Chris.
No, I think it's funny that like Tony, it's just something that I run into a lot. In fact, last week I was teaching a class. We spent a lot of time on this. Just a few days ago on Monday I was teaching a class. We were focusing on this, but the class that I was teaching on Monday went into the Fluke Networks, NetScout, whatever you want to call it, TrueView, and how that analyzer, and like Wireshark as well, it's nice that they delineate between a retransmission, which is like Tony just mentioned, a packet that you see twice, or an out of order. So if the loss is upstream to you, then you don't see the original packet. You see the second one, and it comes in out of order. So just being able to determine where the packet loss was by the nature of the way the analyzer will report it. So if it's a retransmission, that means it happened past you. If it's an out of order, then that means it's upstream from you. But I think for me, this is just all speaking to the point where this is one of the reasons why I'm such an advocate of dual-side capture. Because if you have both sides simultaneously, then you can absolutely empirically see a retransmission and how the network is handling it, and the timers from both perspectives. So But yeah, it's an excellent point to talk about. I think you covered it well, Tony.
Thanks, man.
You did good, Tony. And you also brought up the fact that a tap is always going to get your best timing. Okay? Span is not going to give you the best timing, especially if you're in RTP. If you're looking at video and audio and you're using span port, you're not going to see any real bad events. You may see delays, but you're not assured of what the delay is, and because it grooms it. So it's yeah. And I like the fact that if you can look at it from both ends, it's sort of like I had a guy the other day that wanted to define if his security perimeter worked. Okay, and he says I got a tap and I got a data scope on this side of it, but I can't really tell if it's working right. And I said, well, why don't you put a tap on where it first comes into your security perimeter and look at both sides, and then you'll be able to see what's being broken down and not getting through. Okay, and so comparative analysis is always a great way, especially when you're dealing with timing events. So this is a great think tank stuff.
Yeah, well, and I'm struggling how I'm ever going to write this up, but I'm running into quite a few issues with people using packet shapers or bandwidth shaping, and there's different ways of doing that, right? And you see that, I'm not going to say quite clearly, but you see the effects of that when you have a trace on both sides, because sometimes you're not dropping packets, you're being shaped, and the shaping mechanism and algorithm is, guess what? You're done. I'm dropping all this extra stuff. You can sort this out later. Whereas some other products say you're done, but I'll buffer this, and I'll give it to you on the tail end or a little bit later. And every single one of those have their distinct patterns, and I'm finding that's being quite the issue. Even on a personal note, I have an internet connection that just got upgraded today from a different internet provider because the previous one decided to put packet shaping. And what that meant was they just drop. They discard anything past your settings, which meant a voice call was totally unrealistic and nothing worked well anymore. But when you do a speed test, guess what? It's what you're paying for. And I told the vendor, I said, yeah, you might be giving me what I paid for, but it's not usable. Unless somebody's just surfing and checking email, it's not a usable service. And then I talked to the second provider, and I know him very well. I helped him build his network. And they don't just drop stuff. They let you burst over it for a period of time, but if it continues, then they'll shape you down a bit. But I have the exact same speeds from both carriers, but just because one guy shapes it differently than the other fellow, this is a usable connection, and the other guy's not. And the second guy's right up the street. He's on the same network as I am, so he would know fairly quickly if his system's working well. But again, you would see that evidence when packets are being delayed and or dropped from either side. So that's a whole other, I'm going to say, kettle of fish right now, because that's pretty tough to replicate and write up. But I'm running into that more and more with corporations that bandwidth shaping from the servers or from the cloud or from the routers. You can do this stuff anywhere where you want to mark your QoS, especially on Wi-Fi, because people are getting all uptight about their Wi-Fi performance and putting more video and audio on it. So this is just another technique that I'm using in those types of examples.
Well, here's a leading question for you then, Tony, and I guess also to Chris. What's an acceptable rate of packet loss? Networks drop packets, so we often talk about excessive packet loss, and we see it, and it's impacting performance. I think we, as an industry, we sort of lack a benchmark, don't we? We lack a thing that says for this grade of circuit, like the internet or private circuit, packet loss rates shouldn't be greater than such a number. There used to be, way back in the day, there used to be some CCITT guidance, but I haven't seen anything for years. Do you have a feeling on that?
Sure, I'll jump in first, and I'll let Chris take the back end of it. I cheat a lot when I talk about this topic because there's too many variables. So I first tell, especially corporate customers, if you own the network and you own what's at each end of it, then you can probably tolerate a lot less, and your spec should be a lot tighter. But the other sentence I throw in is we should find out what good and bad means from the customer experience first. So if Mary does a data query or logs in, and it takes 3 seconds, and that's what it should be, and everybody's happy, but that equals 10% packet loss, well then 10% packet loss is fine. But if Mary logs in and it takes 30 minutes and there's 1% packet loss because it's UDP based and everything gets all uptight and dies, then that's bad. So not to worm out of it like a consultant, but that's kind of how I slant my answer. Chris?
Trouble before Chris jumps in. Trouble with that is, if you go to a carrier, he's giving you an IP service. Whether you're passing TCP, UDP, what do you say to him? Do you say, you're dropping 2 packets, I'm expecting this level, you know? Difficult.
Yeah, when you add, and that's why I started off with if you own your network. When you don't own your network, then yeah, that's a whole other conversation. You got to find somebody who's reasonable, which sometimes is pretty tough to do.
Yeah, I would completely echo what you said, Tony, about it all depends on how much you own and what you can control. Because hey, if between you and your remote office there's this massive cloud and you don't control any part of that network and you're going through 15 boxes that you don't control, well, I think in most cases it's tough to really get an SLA out of these guys too, because they're running up against that same problem. Like, what is an appropriate SLA for loss? And but I'm like Tony. For me, I've just always advocated, if you control it, then do your best to get down to 0. And it's interesting what I'll find in my classes. I have a trace file that I really like to use in training, and it has some examples of, it has simultaneously in one TCP connection, it's got like a 20-second response time from the application server, but it also has some retransmissions. So I'll throw that to the class, and I'll ask them, what do you think root cause is here? Why was this slow? And just because in Wireshark, when we see packet loss, when we see previous packet not captured, when we see dupacks, when we see this and that, they're ugly. So they see all these black lines across the screen, and they go, oh man, that's definitely the problem. That's absolutely the issue. It's packet loss. And that's when I make the point, well, you see down here, just because it's not a color, and just because it doesn't have some bright flashing strobe light on it, this is the real root cause. It's this 20-second response time. That's what people are calling you and complaining about. It's not the extra 300 milliseconds that we lost due to retransmissions, which is important, but it's not as important as the slow application response time. So for me, that's what I try to really advocate in my classes is, hey, if you have, like Tony just mentioned, if 3 seconds is acceptable and it gets up to 5 and people start complaining, well, what is that 5? What is that pi of 5 made up of? How much of the wedge is due to retransmissions? And if it's a significant amount, well then, hey, that's not acceptable. We got to go attack that. And for me as well, I think in doing network health assessments, it's trying to get rid of the I should say the low-hanging fruit when it comes to retransmissions. If we have duplex mismatches, if we have cable problems that are causing FCS errors, okay, come on now, it's 2015. It's time to resolve that stuff. It's time to, if we have output drops because of congestion, well, I think that's something we're always going to have to deal with, because typically a WAN connection is always going to be smaller than a LAN connection until everything's 10 gig everywhere. Even on the Wi-Fi, but just the low-hanging fruit problems. Yeah, well, until we can get there, it's the low-hanging fruit problems that cause packet loss, and those are things that I still see out there. I still see duplex issues. I'm still seeing bad cables, just things that we can resolve in the networks we control that could really drop that the level of retransmissions, packet loss down to hopefully a minimum.
The one thing I liked about what you said, though, is winding back a bit to where you talked about taking the pie and working out how much of it is attributable to service time, how much of it is attributable to retransmissions and network delays. That is definitely the way to go, because what I see is people who buy network analyzers, they run them up, they see loads of errors, and they go chasing after absolutely everything. It's like, I don't know how you get on doing that, but it sounds like a never-ending job, instead of finding out actually what is the thing that's impacting the performance for our users. So So they're converted there, definitely.
Well, that's why at the packet level, like with those trace files that I was talking about, what I'll take a look at is, okay, so this, to connect to this application and to run it, it took 30 seconds. So, all right, guys, now go find where was that 30 seconds spent. It was spent somewhere.
Yep. It
was spent either on the client, on the network, or on the application. And which piece of the pie is the biggest? And if the network's the biggest, well, then now we're talking, which goes to what Tony was talking about. However, for me, I just find even when transmissions are present, a lot of times I'm not called out too often just to troubleshoot retransmission stuff. Usually there's some component of application delay as well. So I try to, and usually that's a lot larger than some retransmission events that happen. So it's really just trying to identify in the noise what are the biggest contributors to delay overall.
Yeah.
So,
when I was teaching in general, we used to always use 2% as the bottom, and if packet loss got up to 5%, it was catastrophic. Okay, and then recently I saw a guy that had a 10 gig fiber system, and he spent all this money to put this fancy system together and bought absolutely the cheapest connectors and I've ever seen. And if I would hold the connector a little bit to the inside, his drop packets would actually go down. But if I let it return to the stressed port, his packet loss went up. So, you've got to be, like y'all said, you've got to be intuitive in this and go and eliminate. I mean, for $10, we bought a new cable that had good connectors on it. He thought I was wonderful because I cleared up. I said, that's just the beginning.
I thought you were going to say you had a full-time job to hold the cable to one side.
Well, that was the best. I got actually better pay at Walmart, so I went there. But yeah, I mean, but it's ridiculous. And Tony brought this up not too long ago, and Chris and I have talked about it 100 times. Is people really don't do very good baselining. They don't really know where their delays at, where their corruption points are. They don't even know what's acceptable. I mean, I've gone into people's networks and they're complaining about everything slow, but when I do just a layer 2, layer 3 benchmark, they're losing 25%. I saw one that was 27% of the frames were bad. Well, that's the problem right there. Let's get that cleared up. Then we can look at all the other issues. But people just don't do it intuitively, like they were saying. I agree with you. This is a major issue.
Right, and then
we should probably wrap up the show. But I would like to give sort of everyone the last chance to sum up to comment. But as a reminder, just a reminder, for those who are watching the show live, if you could find the button on the left-hand side that says Q&A, and you can ask some questions, and I'm sure Tony and anybody else would be interested in answering them. Before I turn the table, I can't help but to give Tony just one word of advice. You never know when you're going to be pursuing a career in politics. Don't ever say I cheat a lot on the open web.
He'd be the only politician that was telling the truth.
Yeah, I know. Honesty will kill you every time, won't it?
Okay, so with that, Paul, what's your last comment?
I thought it was a good presentation, and just a small snippet there, but such an important issue. So yeah, great stuff. Well done.
Thank you, Paul. And Chris?
It's been nice to be back on this with you guys for sure, and I think me being here just really illustrates the point that you can never underestimate the users. Sometimes it's user error, and as you notice, I don't have a name bar right here. For the past half hour, I've been fighting with Google Hangouts, so there's people like me out there that fight with applications, and sometimes it's not about being down in the weeds. It's just finding the right thing to click. So next time, I promise I'll find it. But my name's Chris Greer. See,
what happened is that if you actually come on the show every week like the rest of us, you don't have to. It just works. Otherwise, it just hides things from you.
You're right.
Google is too smart.
Well, what we do, Chris, is we buy you a T-shirt with Chris Greer across it, and then you sit in front of the camera.
There you go.
I like that. I really like that. That's a good
We
idea.
should
We'll
all
do that
we
next
should all
time.
do that. We should all do that.
We'll
Hey
do that
Tim.
next time.
So in addition to your last comment, to what Tony had talked about, maybe just giving us an idea of what's been pissing you off this last couple of weeks.
You talking to me or Tony?
No, Tim, you. Yeah,
Oh.
because a lot of stuff's happening right now between China and U.S. and somehow instead of holding their feet to the fire and saying, stop bugging us, we kind of say, well, we all do it, right? That's what our president is saying right now.
Well, that's crap. I mean, they just arrested a 55-year-old woman in China for being a cyber spy, and my comment was, what does China have that's not stolen from us or UK or Western Europe? And that's kind of like the turning the tables. We're going to arrest you, but we don't do all that. And yet we have huge evidence that they've been involved in in the Anthem attack, which gave them millions of people, the OPM. It just goes on and on. So I got upset about that and wrote something on Google Plus yesterday. But I think what upsets me more is kindness. I'll tell you a short story. I was in Walmart, and I had my hat on that has the American flag and my name on the back because I still was doing some stuff for one of the teams. And a guy walked up to me and said, "Your hat is offensive to me." And I looked at him and said, "Well, I want to tell you this. I don't want to hurt your feelings, but your face is offensive to me."
Hey, look, you were at Walmart. You were asking for it.
Yeah, that's right. And the manager knows me, so he came over. He heard about from one of the employees. They came over and told the guy to leave. But I think we could solve a lot of, when we come together as a team, none of us are perfect, but we work together, And
Tim,
that's what we need, a little more work together.
I asked you that question with something specific in mind. I think it's time for us to do another Homeland Security, and maybe we should do it after this quote-unquote state visit between the two world power. And we should talk about the things that they didn't do. I mean, that is actually threatening our liberty. So anyway, I don't mean to die off on that. Tony, thanks again.
I wanted to say thank you, Tony, Paul, and Chris. You guys are great friends. You've been incredible authors and writing stuff all these years. And you've really, as I used to always say, you're pinching them in the right spots to get people aware, And when you leave any of these sessions, the first thing anybody should do is say, hey, I need to figure out how to do benchmarking, pinpointing of targets, and read those articles that you guys have all written and videos you guys have all done. But thank you for being such great companions, friends, and authors, and being out there with us as technologists.
And congratulations again, Tony, for writing for network computing. So I think this is great. I think that having articles, written articles, and then complementing it with kind of a video presentation and some questions and answers, and especially today with some great peers. I think that's all very good.
Yeah, and I just, one last point, I think this might be another topic one day. Everything we talked about on the network side only gets a lot more curious and or worse when you start migrating all the servers into the cloud. So just keep that in mind, Mr.
Work
and Mrs. Customer.
is never done.
That's right.
Yeah, the cloud will call whodunit, because then the cloud, you really got to be a detective to find out who done it.
So Paul, hopefully work on your schedule. Hopefully we'll see you soon.
Yeah.
Okay. So with that, I'm going to close the show. Thanks, Chris. Thank you, Paul. Thank you, Tim.
Nice being here, guys.
And thank you again, Tony. Bye-bye.